Hi there guys, and we're going to have a quick look today at what we call the discriminant. Now, you've got three pictures in front of you with a simple question. What would happen if we tried to solve these following functions? So what I mean by that is we have our quadratic, we set it equal to 0 because that's where y is equal to 0. And you'll notice I have, well, the x-axis is like a tangent to this curve. It only meets at one point. Here we have two intersection points, and the one on the right, we don't have any. So actually what would happen is we'd get one solution here. We could say there is one root value to this parabola. This one we would have two solutions. And this one we would get an error. We wouldn't be able to solve it. We'd end up trying to square root a negative. That doesn't work unless you use imaginary numbers. That's for another video. And this would be zero solutions. So as mathematicians, we wanted a way of identifying what will happen before we even try to solve it. So, and that is called the discriminant. And you would have recognized this before from the quadratic formula. It's the part that's underneath the square root symbol. Now, basically, if we go back to here, if I just write that again up here, b squared minus 4ac. So what will happen here is when you work out the values of b squared minus 4ac, which is just the coefficients of any quadratic, if you get a 0 out of here, when you square root 0, you get 0. So this will happen when b squared minus 4ac is 0. If you get a value, which is what normally happens when you use the quadratic formula, bigger than 0, you end up getting two solutions. And when you get b squared minus 4ac is less than 0, you can't square root a negative, you get no solutions. And that's something you need to remember. Okay, so let's have a look at this function here. So they might say calculate the value of the discriminant. So b, well, b is minus 6, so that's minus 6 squared. Take away 4 lots of a, which is 1 on there, times c, which is minus 16. So we have 36, 64, so plus 64, and we get 100. So the value of the discriminant is 100. So b squared minus 4ac is greater than 0. Therefore, this graph will have two roots, I'll say. Okay? Which means it will look something like this. Basically, two intersection points. I did a little bit more in my head to think where the minimum point would be, and I just made sure I had a negative y-intercept as well. So it looked pretty similar to that. Okay, this one slightly more complex, but not for the discriminant. So b squared minus 4ac. So b is 2, so 2 squared, minus 4 lots of a, which is also 2, and c is 9. So we have 4 minus 72, so you get minus 68. So b squared minus 4ac is less than 0, therefore no roots. So don't try and solve it, it will not work. It's going to be somewhere up above the x-axis. Let's put it into something a bit more meatier. These are sort of questions you will be asked. So we have a function, but we've got a little unknown value here, k. But we are told this function has equal roots. What that means, I should have said this earlier, an equal root means it's like one repeated root rather than two unique roots. So it has equal roots. Right, so it doesn't mention using the discriminant at all, but you need to understand that this is what they are asking for. So let's go ahead and work it out. So b squared minus 4ac. So b this time is k, so k squared minus 4 lots of 1, a is 1, and c is 9. Now, if it has equal roots, the discriminant would be equal to 0. So we can say this is equal to 0. We end up with k squared minus 36, 0. We've got a bit of dots here. You could pop it on the other side, but for now, it's a good habit to always factorize. So we have k to be minus 6, and we have k to be 6. Now, a lot of people get confused here because they've got two different answers, and they think, well, surely I should only have one. What this is meaning is this function of x could be x squared minus 6x plus 9. And if you were to try and solve this, you could see that the only solution you would get is 3. Okay. The other possibility, you could have had a positive 6x. So when we solve this one, so if we were to solve this, we would get x equals minus 3. So again, only one repeated root, therefore has an equal root. Okay, this one's slightly harder. Now you'll notice this quadratic is not set up to solve, so we've got to get this constant value over here. And when we do that, you've got to think, are there any like terms? And yes, there are. This k is also a constant value, so they would join together. Right, so that's equal to 0. Now we have two real roots, so that means there's two unique intersection points on that axis. So b squared minus 4ac now will be greater than 0. Just set it up. So b is 4, so I'm just going to write 16, minus 4 lots of a, 1, and c this time is k minus 2, and that has to be greater than 0. So 16 minus 4k plus 8 is greater than 0, just expanding that bracket there. Let's collect all our like terms. We've got 24 minus 4k is greater than 0. A few things you could do here. You could divide everything by 4. I'm not going to bother yet. I'm just going to put 4k on this side. Now k. Right, that really upsets me like that. So that's the same as k is less than 6. So when k is less than 6, this will always have two real roots. If it's equal to 6, it won't. Or if it's more than 6, it won't. And there you go. So have a go at some of the questions I'm going to set now. If you end up with a quadratic here, just remember you have to find your critical values and then do a critical value sketch and look at where it satisfies the inequality. What's happening?